All right, so we are now starting a new chapter, as you see, chapter 4. And the first thing we're going to talk about, I think this whole chapter, anybody got their book open? What's the name of the whole triangle, or the whole chapter? Is it triangles, or what's the actual name of the chapter? Congruent triangles, that's the name of the chapter? Okay. So we know what congruent means, right? And we know what a triangle is. We've actually talked about both of those things. But now we got a whole entire chapter that's going to be talking about triangles that are congruent to each other. Well, before we do that, we're going to have to talk about some triangles, and we've got several types of triangles that we're going to talk about, and then we'll get into that. So there's 3 right now that we're going to talk about. So there's 3 basic types of triangles. Now, what's the symbol for a triangle? Do you remember that? It's a triangle. Very good. So I'm just going to put triangles. Is that all right? Apostrophe S? All right, so there's 3 types of triangles. According to their angles, I'm going to put that in parentheses. Because there's 3 types of triangles according to their sides. We're going to do that in a minute. All right? So there's 3 types of triangles according to their angles. So let's draw. Oops. Let's draw this. Let's draw this. Okay, and right here. Well, I didn't quite hit it, but you get the idea. All right. Now, all 3 of these angles right here, now it kind of looks like that could possibly be a right angle, but let's say they're all acute angles. All right, so this is less than 90. This is less than 90. This is less than 90. So if you have all 3 acute angles, give a wild guess of what you're going to call this triangle? An acute triangle. That's right. All right. So it's an acute triangle. And when does that occur? When you have 3 what? Acute angles. All right. And there's my symbol for angle. I'll just do it like that. Shorten things up a little bit. All right. So it's called an acute triangle when you have 3 acute angles. That's easy enough, isn't it? What about this? Do you know it's a right triangle right now? Do you? Not till you see the thing. What thing? The little box, right. Okay. Well, I don't know. This could have been off a little bit. This could have been 89.999 degrees. Is that a right triangle? Nope. All right. It's got to be what? Exactly 90 degrees. All right. Now, what is it? Now it's a right triangle. Okay. So I'm just going to shorthand right. Is that all right? Okay. RT. Triangle. So it's a right triangle. Now, an acute triangle had 3 acute angles. What must be true about a right triangle? 3 right angles? No, just 1. Okay, 1 right angle. Okay, you can only have 1. We're going to talk about this in a second. But you probably, well, we'll wait. We'll wait. All right, now what do you think I'm going to draw? Very good. Yeah. So, there we go. There we go. All right. So this angle right here, what does it look like it is? Obtuse. And I'm telling you it is. Okay, so that's obtuse. But what are the other 2 angles? They're acute, aren't they? Does that mean it's an acute triangle? Because I got 2 acute angles? No. All right, I have to have how many angles to be an acute triangle? I got to have all 3 of them be acute. What does this have? It's just 1, what kind of angle? Obtuse. So we call this an obtuse triangle. And it has 1 obtuse angle. It's pretty easy, right? Yeah. And we're going to refer to those quite a bit, so we need to know that. All right. Now, what did I say we were going to do? We had 3 types of triangles according to their angles, and now we're going to have 3 types of triangles according to their what? Sides. I'm not going to write that first part. You can write that first part if you want, right? What did I write? 3 types of triangles, okay? So 3 types of triangles according to their sides. All right, so let's do this. Let's do this. Let's do that. Let's do this. Let's make it more look like that. All right. Now, I don't care about the angles. Well, I still didn't make it look very good. Why can't I? Here, let's start this again. Let's make it look like this. There we go. This is going to be better. All right. Now, we're looking at the sides. We don't care about the angles. This is an obtuse triangle, right? You can look at it and kind of see it's an obtuse triangle. But I'm looking at the sides. So this side is that long. This side is this long. And this one is this long. What does that mean if I have one tick mark here, 2 here, and 3 here? What does that mean about the sides? None of the sides are equal. They all have different lengths, exactly. Everybody see that? So none of the sides are equal. So I'll put no sides of this triangle are equal to each other. And we have a name for that. It's a weird name. No, it's not isosceles. It starts with an S. It's scalene. All right, it's a weird word. Now, we don't talk about that very often. All right, the next two we're going to talk about quite often. All right, but this one we don't really mess with too much. There's really not much to know about it, except just none of the sides are equal to each other. All right, that's all you got to know about that. Everybody good? All right, now let's draw another type of triangle. There. Now, here's what's given. I'm given that this side is equal to this side. All right, so how many sides are equal on this triangle? 2. All right. To tell you the truth, the definition says at least 2 sides. So at least 2 sides are what? Are equal to each other, okay? So when you have at least 2 sides, which means I could have what? All 3, all right? But most of the time when we refer to this kind of triangle, most of the time we refer it to is if you have exactly 2 sides, all right? Most of the time that's how we would refer to it. But technically the definition is at least 2 of the sides are equal. And we have a name for that. And we've said it already, but we said it for the wrong triangle. This is isosceles. Watch how we spell it. Everybody watch. It's isos. So how do you spell isos? I-S-O-S. And then the Celes, C-E-L, like Celine. Well, do you even know this girl? Celine Dion. Do you know that name? Okay. How does she start her name? With a what? With a C, right. So that's how I think of it. Celes, all right? Isosceles. Everybody got it? That's how you spell it. Now, I don't take off points if you don't spell it right or anything like that. But, it's nice to be able to spell the language that we speak, okay? So it's called an isosceles triangle when at least 2 of the sides are equal to each other. And normally, like I said, we normally just say it's isosceles if exactly 2 of the sides are equal. But it could be 3. Now, we have special names. The 2 sides that are equal to each other, we have a special name for it, and we call it the leg of the triangle. All right, so the 2 sides that are equal, we call the legs. And then the side that's not equal, we call the base. All right, so every once in a while, we'll refer to that. Now look at the angles that are here. You see this angle right here? And you see this angle right here? We're going to learn something later about the relationship between those 2 angles. What do you think off the top of your head might be true about those 2 angles? Yeah, they are equal, okay, if you have an isosceles triangle. But we'll specifically talk about that later on. But these angles have a name. We call these the base angles, all right? So if this side is the base, this angle is the what? The base, it's supposed to be a B, angles, all right? So right there and right there are the base angles. We have a special name for that angle right there that is not, see how this attaches to the base? This angle right here does not attach to the base. It just connects the 2 legs, doesn't it? Okay, we call that the vertex angle. We've used the word vertex before, haven't we? But specifically on an isosceles triangle, we call it the vertex angle. We probably won't refer to that all that often, but just in case it pops up, then you'll know what they're talking about. All right, how many types of triangles do we have according to the sides? 3, so I've only given you 2 right now. So let me give you another one. Actually, I have a thing. Oops. No, I don't want that. I just want to click. There we go. That's what I want. I'm going to make 3. Click that. There we go. That's what I want. So what do you think's true about all 3 sides of this? Yeah, all the sides are equal to each other. Okay, so watch. I'll put 1 tick mark here. Then I'll do what? 1 here and 1 here. All right? So you got a triangle with all 3 sides equal. So all 3 sides are equal to each other. And we have a name for that. Okay? Equilateral. Very good. And we've actually, now we didn't, have we used equilateral before? We used quadrilateral. When did we use equilateral? In the same chapter. We just started this chapter. In the other chapter? It seems like we had, oh, you know what? I think it was another class that I was teaching. I think that college algebra class. We did that. Anyway, equilateral. Lateral means sides, okay? And equa, of course, means what? Equal, right. All right, so it's called an equilateral what? Triangle. It's not an angle, equilateral triangle. Okay, when all three sides are equal to each other. Everybody good? That's easy enough, isn't it? All right, you guess it is. All right, so look, if all three, now this is it's getting a little ahead of ourselves here, but just take a wild guess. If all three sides are equal to each other, do you think you can say anything about those angles? They are equal to each other. Now, is really stretching a little bit. We're going to talk about this in the next thing. What do you think the degree angle for each of the angles are? Why 60? Where'd you come up with that? That's right, because it's all 180. Now, we haven't even said that yet this year, I don't think, have we? That all three angles are 180, but that's something that you learn, right? Probably middle school somewhere down the line in a math class. You probably learned that all the angles add up to 180 degrees, right? So that's not brand new. But has anybody shown you why the angles? Well, you could say, well, they add up to 180, but why 180? Why do all three angles add up to 180? That's the thing that you probably haven't been shown. Probably. Because it's what? Because it's not a circle? So everything that's not a circle is 180 degrees? No. Yeah, why is it 180 degrees? Why 180? Why not 200? Why not 100? Why 180? Okay, all right. That has something to do with it. But I could take this line, this side right here and this side right here and spread that out to make a line, right? Well, I could take this, right, and then have it come down like this so it makes a straight angle, and that's 180 degrees, right? But here, you're on the right track, though, okay? I'm just kind of messing with you a little bit. I'm going to show you why. Then I'm going to show you a little demonstration that I had a class last year. They like freaked out. They thought it was the most amazing thing ever. And it's not that amazing. I mean, it's kind of cool, but it won't translate to YouTube. Yeah, absolutely. All right. Now what I'm going to do is I'm going to change colors here, and I'm going to draw a line that goes like this. What do you think that line is to this one down the bottom? Now, I didn't show it. I didn't say it, but it looks like it's parallel, and I did make it so it's parallel. Okay? So those two lines right there are parallel to each other. Everybody good? Remember what we learned about the different angles when you have parallel lines cut by transversal? Do you see a transversal here anywhere? Sure you do. This thing right here, right? That connects this parallel line to this parallel line. So that's a transversal, isn't it? Agreed? Yes? No? All right. So what we're going to do is I'm going to number these angles. I'm going to call this 1, 2, and 3. Okay, good. And then I'm going to call that 4 and 5. Everybody with me? All right, so this is why angles 1 plus 2 plus 3 equals 180 degrees. So we already know from the other chapter what's true about angle 4 plus angle 2 plus angle 5. That equals 180. Why? Because it forms a straight line. It forms a straight angle. And how much is a straight angle? 180 degrees. So you could agree with that, couldn't you? Because that's a straight line. All three of these angles form that straight line. So that's true. Now, here's what we learned in the last chapter that we're going to apply to this that you've probably never seen before. It would be my guess. What do you think might be true about angle 4 and angle 1? They're equal to each other. Why? Give me a reason. Two parallel lines cut by transversal. What's the relationship between 1 and 4? They're alternate interior angles. Exactly right. Okay, we're kind of doing a proof right now. You don't even know it. All right, but we're kind of doing a proof. Okay, we're not going to write it down formally, but we're doing a proof. So instead of angle 4, what can I replace that with? Angle 1. Now, angle 2, I don't have to worry about because it's one of the angles in my triangle, right? So I'm just going to write down what? Angle 2, okay? Plus, now look at angle 5. Do we know anything about angle 5? It's equal to what? It's equal to 3. Now, it doesn't mean it's equal to 4, so I'm going to put how many? I'll put 2 arcs here, and then I'll put 2 arcs here. But we do know that 5 and 3 are also equal to each other. Different transversal, though, right? Right? Over here, we use this as our transversal. This time, we use this as our transversal. So 3 and 5 are equal to each other. Give me a reason. You already said it. Say it again. Alternate interior angles are equal, right? So 3 and 5 are equal. So instead of writing angle 5, what could I write? Angle 3. So guess what we just did? We just proved, we just showed that angles 1 plus 2 plus 3 equals 180 degrees. So I just showed you that it's not 200 degrees, it's not 100 degrees, it's what? It's 180 degrees, okay? So all 3 of these angles add up to be 180. Isn't that cool? Let me show you another little thing. Let me take this microphone down. I remember how to do this now. I think I can. I'm gonna make this a triangle, okay? So I'm taking this, here, let me put this. Now, if anybody's watching this on YouTube, you're not gonna be able to see, but I'm taking a piece of paper, just a blank piece of paper, and I'm just making a triangle. I'm cutting a triangle out of it. Okay, so there's my triangle. And it's not perfectly straight, a little curvy, but it's close. Now, watch what I'm going to do. Everybody watching? So what I'm going to do is I'm going to rip off. So there's one angle, right? Everybody see that? All right. I'm going to take the other angle. I'm going to rip that off. There's the other angle. Agreed? And then I'm going to rip this angle off. So watch what I'm going to do. See if I can do this just with my hands and not put it on. So I can put those together like that, right? So again, this is one angle of the triangle. This is another angle of the triangle. And guess what? I'm going to put this right there. And what does it form? It forms a straight line, doesn't it? Okay. So what must be true about this angle, and this angle? They must be what? 180 degrees. And I didn't cut that triangle like a specific way, right, so that it works. You can make any triangle. You can do it to right triangle, obtuse, and acute triangle. Doesn't matter. Isn't that cool, though? All right. You didn't flip out so much like the other class did, but I could see it in your face that you're pretty impressed, aren't you? All right. So all 3 of those angles add up to 180 because they form a straight line. You can try that yourself. A little parlor trick for you. All right. Isn't that cool? So that's why, okay? And it's good to know. Not all the time will we worry about why stuff is equal. Sometimes it's way more complicated. But when things are fairly easy to understand, that's what we're going to try to do. All right? Now, with that said, we probably won't finish the lesson today, but what did I put on the... Did I put that we were going to finish it and gave you homework? All right. So we'll put off the homework, okay, until Monday. All right, but let's do a little bit more, though. Now, we have a thing called a corollary. Have we talked about that before? Seems like we have. I don't know. Maybe. Corollary. Basically, we have postulates. Postulates are just an accepted fact, right? And then we have what? What's after that? Theorems. And theorems, you can do what to them? You can prove them. And we kind of just did, right? That whole thing about the interior angles of a triangle adding up to 180, or the sum of the angles are 180. That's a theorem, right? And we basically just proved it. And then a corollary, it's a theorem, so it can be proven, but it's a theorem that has, or it's a like sub-theorem, if you want to call it that, right? You got this one big old theorem, and then you got these little sub-theorems underneath of it. So it relates to the theorem that we just talked about. So they usually call that a corollary, okay? So here's what it says. We're going to specifically draw a right triangle. All right, so this isn't just any triangle. This is a right triangle. All right, there's a right. Now it's a right triangle. Okay, and let's do this. Let's call this A, B, and C. And let's change colors for my writing. Okay, So here's what the theorem says. It says the acute angles of a right triangle. Which ones are the acute angles of this right triangle? Well, first of all, which one is the right angle? That's easy. A. Which ones are the acute? B and C, right? That's acute and that's acute, all right? Now, we just learned that all three of those angles do what? Add up to what? Right, so watch. Angle A plus angle B plus angle C is going to equal 180. Agreed? Because it's a triangle, and all three angles of any kind of triangle, not just because it's a right triangle, but any triangle is 180. What did you just tell me about angle A? Angle A is what? It's 90 degrees. So let's replace that with what? 90 degrees. So 90 plus angle B plus angle C is equal to 180. Okay? What do you think we can do with that 90? Let's do a little algebra. Subtract from both sides, right? So subtract a 90, and look what we get. We get angle B plus angle C equals what? 90 degrees. 180 minus 90 is 90. Everybody got that? So what can we say about angle B and angle C? They add up to 90. Don't say they equal 90, okay? I know what you're thinking. You're thinking if you add them up, they equal 90, but don't say they equal 90 because angle B is not 90, agreed? Angle C is not 90, but they do what? They add up, or the sum of the angles. What do I mean by the sum of the angles? What does sum mean? They add up to, right? Okay, so the sum of the angles is 90 degrees. We have a word for this too. I think we may have talked about it. What's the word when two angles add up to 100, or any amount of angles add up to 180 degrees? That's supplementary, right? We did that because consecutive interior angles, remember that? We have a word for angles that add 90, and we call it what? Complementary. All right? So complementary angles do what? Add up to 90 degrees. So what can I say about angle B and angle C? They are what? Complementary. And that's what our corollary says. Again, it's like a little mini theorem, all right? It's a sub-theorem, I should say. So the theorem says, I didn't write it down, it's in the book, but if you want to write it down, you can. They're complementary, which means they add up to 90. So the theorem says this: the acute angles of a right triangle are complementary. Everybody got that? So any right triangle, the other two angles will always add up to 90. So what if I told you that this was 30 degrees right here? What could you tell me about angle B? It's 60. And I don't have to do, and a lot of people, even though I teach this, a lot of people say, oh, 180 minus 90 minus 30. Do you have to do that? No, you could go right to what? One little thing. You could go right to what? Instead of 180 minus 90 minus 30, you could just say what? 90 minus 30. Agree? All right? Because 180 minus 90 is always going to be 90, right? So you're always going to get rid of that one because you know it's a right triangle. So you just end up with 90 minus 30, which is what? 60. All right? So that's going to be 60. All right? So if you have a right triangle and they give you one of the acute angles, you can always find the other one just by subtracting from 90. Simple, right? Yeah. Do you remember we did that equilateral? Let's do some math on this. Okay, now you did it in your head, but let's show you the algebra. All right, so let's say we don't know that angle. You already told me what it is, and you know what it is, but let's just say we didn't. Okay, so we'll call that x degrees. Now remember what we said about an equilateral triangle? All the other angles are going to be equal to. We haven't officially said that just yet, but it's true. All right, that's what we're getting at right now. So these angles are all equal to each other. So what do? They add up to be what? Right, so x plus x plus x is 3x. And what do they add up to be? 180. And then what do? Divide by 3. So you just did this in your head anyway, right? I'm just showing you the math that goes with it. So x is 60 degrees. So all those angles are 60 degrees. Okay? I think that's a good place to stop. If you want to start on the homework, because there's going to be some problems on the homework we haven't gotten to yet because we didn't finish the lesson. But it is 1 through 16. So it's 1 through 16. I don't know how far. Has anybody got their book open? See how far you think you could go with what we learned today. About 8. All right, so you might be able to get done half of it if you want. I'm not going to collect it Monday. So if you don't want, okay, you could just wait till Monday and do them all. Or you could do a little bit today, all right? If you have some free time today, just look at it. Since it's fresh in your mind, all right, go ahead and try them. And then on Monday, then you only have 8 problems to do, all right, after we do the new stuff. Everybody good? All right. You guys have a good weekend.